Okay, so let's look at what happens with the graph. The graph of f and f inverse are related to each other in this way. If the point AB lies on graph f, so that's point AB, then the point BA must lie on the graph of the inverse and vice versa. This means that the graph of f inverse is a reflection of the graph of y in the line y equals x. So here this dotted line represents the line y equals x, and it's a reflection. This function f is a reflection of the inverse, and you can see that AB is on this side and BA is on this side. So that happens with the graphs. So it says verify graphically that the functions f of x is equal to 4x minus 1 and g of x equals 1/4 x plus 1 are inverse functions of each other. So first we would have to graph f of x. You can use the y-intercept or you can use a table of values. Okay, and then for g of x, we have 1/4 x plus 1. We can do the same thing. So if we have our graphs, I'm going to use y equals mx plus b for this one. So we have -1 is your y-intercept. And then my slope is 4. So that means I'm going to go up 4. So 1, 2, 3, 4, and then to the right 1. Okay, so this is my line. And then for the second one, I'm going to go ahead and use a table of values. So if I use -1, 0, and 1, so here we get 1/4 plus 1/4 is 2/4, which is a half. So we plug in the 1 for x here. 1/4 plus 1 is 1/4 plus 1/4 gives us 2/4, which becomes a half. If I plug in 0 here, then I get 1/4. And if I plug in -1 here, I get -1/4 plus 1/4, which would be 0. And then I guess I can use a table of values here as well, so we can compare the values. If x is -1, we get -4 minus 1 is -5. If we plug in 0, we get -1. And if we plug in 1, we get 4 minus 1 is 3. Okay, so let me plot this one here. We get -1 and 0, 0 and 1/4, just somewhere here, and then 1 and 1/2. So this line would look something like this. Yeah, so let's look at the graph on the computer just to get a better view. So the first one is 4x minus 1. And then the second one is 1/4 divided by or times x plus 1. So look at the values there and think about whether these are inverses of each other or not. Okay, so if I was to draw the line y equals x, This is the green line here. Then if I choose a point, 0, -1, then notice here that -1 gives me 0, and 0 gives me -1. So we're switching the x and the y. So that means that these are going to be inverses of each other, and you can see the reflection on this green line. Okay, so I'm going to draw this as a dotted line. And so you can see the graphs reflect on this dotted line. So we say yes, they are inverses of each other. And again, you can pick a point like this one here, -1 and 0. This is for g of x, and f of x, it would be 0, -1, which is on the graph. Okay. So the next one, verify graphically that the functions f of x equals x squared plus 1, x greater than or equal to 0, and g of x equals x minus 1 are the inverses of each other. So we have f of x is equal to x squared plus 1, and they only want us to look at the values greater than 0. So if I was to graph this using the transformations that we learned in the previous section, then my graph looks something like this. However, they want us to consider only from the values x greater than or equal to 0. So that means that we're not going to include this side on the left side. Okay, so if I graph this, we're only looking at this point here. That goes like this. To help me, I just plot in another number, 1. 1 squared is 1 plus 1 is 2. Now this one here is the square root, and it's being shifted to the right. So I'm going to move over to the right one, and my graph will look something like this. Okay, so we want to know, are these inverses of each other? So remember, there's this y equals x dotted line, and this point here is 1, 0, and this point here is 0, 1. So we can see that the values are switched, x and y, 0, 1, and 1, 0. This has reflection on this line, so this is yes, they are inverses. Example 9, use the graph to draw the inverse. So here, first, we can look at the graph for f of x, get the ordered pairs. So this point is -3, -2. This point here is -2 and 2. And then this point here is 4 and 1. Since we're looking for the inverse, I can switch these order pairs. So instead of -3, -2, I can write -2, -3, 2, -2, and 1, 4. So -2 and -3 is right here. 2 and -2 is right here. And 1 and 4 is up here. So my graph will look like this.